In this lesson, we're going to be talking about properties of operations with integers, and our essential questions are: what are properties of math? What are the order of operations, and can I use them to evaluate expressions? What is the commutative property, and what is the associative property? So now that we've learned about all four operations with our integers, we want to start talking about properties of these operations and what we can and cannot do with these operations. So what are properties of math? A property of math is anything that is always true about numbers or operations. And here I've got some basic properties of math listed. Now, these aren't all the properties of math, but these are the basic ones that we should be familiar with or should know at any time. We have one called the additive identity property, and that means that adding 0 to any number does not change the number. So that looks like a plus 0 equals a. So anytime you add 0 to something, it doesn't change the number. We have the multiplicative identity property. That means multiplying any number by 1 does not change the number. So a times 1 equals a, no matter what a is. So anytime you multiply by 1, the value does not change. We also have the multiplicative property of 0. That means any number times 0 is 0, or a times 0 equals 0, no matter what a is. So anytime you multiply by 0, you always get 0. And then we have the additive inverse property. That means the sum of additive inverses is always 0. And we talked about this when we were talking about addition of integers. Whenever you add opposites together, you always get 0. So that looks like a plus negative a equals 0. So those are some basic properties there. We also have something called the order of operations, which you may have heard of. And the order of operations is the order in which operations must be performed in an expression. Now, it's important to do this correctly, otherwise you're going to get the wrong value when you evaluate expressions. So here are the order of operations, which would be good to have in your notes. So the first thing you want to do in any expression is to evaluate things in parentheses and grouping symbols. So we want to perform all the operations inside parentheses, brackets, or other grouping symbols. That's the first priority when we have an expression. Next, we want to evaluate any exponents, and those we see from time to time. Next, we want to evaluate any multiplication or division. We're going to multiply or divide. We're going to perform all multiplication and division from left to right. Now, it doesn't matter which one comes first, but we have to do it from left to right. So if multiplication comes first, we're going to do multiplication, and if division comes first, we're going to do division. And then lastly, the last operations we do are addition and subtraction. We're going to perform all addition and subtraction also from left to right. The same with multiplication and division. So let's take a look at some numerical expressions here, and let's evaluate these using the order of operations. So this first one, we do have grouping symbols. We have parentheses, so we want to do what's inside the parentheses first at all times. So we do 3 minus 4, and that is going to be negative 1. So now I have 5 plus negative 1 times 6. And I have addition and multiplication. I have to do the multiplication first. Now, it's tempting to go left to right all the time, but we always have to pay attention to the operations and do the correct one first. So negative 1 times 6 is negative 6. So I have 5 plus negative 6, and addition is my last operation, and that's going to be negative 1. So I've evaluated that expression using the order of operations correctly. Next one, I have 7 squared minus 4 minus 6 plus 8 divided by 3. And again, I have grouping symbols here. I have the parentheses, so I have to do what's inside the parentheses first. So everything else is just going to get copied. And 4 minus 6 plus 8. Well, 4 minus 6 is negative 2, and negative 2 plus 8 is 6. And then I have the divided by 3. So now I have an exponent, subtraction, and division. I have to do the exponent next. So 7 squared means 7 times 7, so that's 49 minus 6 divided by 3. So now I'm left with subtraction and division. Division has to come first, so I will do the 6 divided by 3, which is 2. So I have 49 minus 2, and that's the last operation I have to do, and it's 47. So that's how I would evaluate that expression using the order of operations. Next one, 15 minus 12 divided by 4 plus 6 times 3. And I've got some division and multiplication. These have to come first. Multiplication and division come before subtraction and addition. And I'm going to do these from left to right. So I have 15 minus 12 divided by 4 is 3, plus 6 times 3 is 18. So now all I'm left with is subtraction and addition, and I'm going to do those from left to right. 15 minus 3 is 12, and then I have 12 plus 18, which gives me 30. And there I have evaluated that correctly. This last one, this bar right here is actually division. So I have addition, division, and more division. But really, when division is written like this using this bar, this is like a grouping symbol. We can think of this as the numerator and denominator in parentheses. So it acts as a grouping symbol, and this is what it would look like written without the division bar. So the numerator and denominator are grouped together, so I have to do those first, and then I'll do the division from the division bar last. So here I'm going to do the grouping symbols, and 14 plus 10 is 24, and 18 divided by 3 is 6, and now I can do that last division there. 24 divided by 6 is 4. So there are some examples of using our order of operations to evaluate expressions. Just make sure you're following those guidelines and always doing the operations that come first. Next, we want to talk about another property called the commutative property. This is a very important property in math that gets used quite a bit. You probably already use it, but you don't know that you're using it. The commutative property says that you can add or multiply numbers in any order without changing the result. So I've got some illustrations of that right here. A plus B is equal to B plus A. You can rearrange the numbers and you can still get the same sum. And likewise, A times B is equal to B times A. You can rearrange the product and still get the same answer. So then I've got a couple examples here. 3 plus 4 plus 5 is equal to 3 plus 5 plus 4. Notice the 5 and the 4 swapped places. You're still going to get the same sum no matter what order you add those numbers. And likewise with multiplication, 4 times 6 times 5 is the same as 6 times 5 times 4. Everything got rearranged there, but the product is going to be the same no matter how you slice it. So let's take a look at some examples where using the commutative property would actually help us to evaluate these expressions. Now you might do this if you're forced to do something mentally. Now if I asked you to do 8 plus 19 plus 2 mentally, you're probably going to recruit the commutative property to help you out, because you'll notice that the 8 and the 2 add together very easily, much easier than the 8 and the 19. So you might think of this as 8 plus 2 plus 19. So the 2 and the 19 swap places, and 8 plus 2 is 10, and 10 plus 19 is 29. That makes our job a lot easier thanks to the commutative property. The next one, 5 times 9 times 2. How might the commutative property help us with that? 5 times 2 is a pretty easy product to do, so I'm going to swap places there with the 2 and the 9. I'm going to do 5 times 2 first, which is 10, and then 10 times 9 is easy to do. That's 90. So again, the commutative property helped us out. This one, 99 plus 37 plus 1 plus 3. I'm noticing that the 99 and the 1 would go good together, and the 37 and the 3 would go good together. So I'm actually going to rearrange this to be 99 plus 1 plus 37 plus 3. And then I can add these however I want. And the 99 and the 1 make 100, and the 37 and the 3 make 40. And that makes my addition much easier, and I get a sum of 140. Very easy to do there. And then likewise, the last one, 25 times 4 is much easier for me to do than 25 times 7. So I'm going to swap places with the 4 and the 7. 25 times 4 is 100, and then 100 times 7 is 700. So you can see knowing and using the commutative property can make evaluating expressions a lot easier for us. What is the associative property? Now, the associative property says that addition or multiplication can be grouped in any way without changing the result. Now, this is a grouping property, so the parentheses can be placed wherever we want them in an expression. We're not really moving the numbers around. We're just changing how they are associated or how they are grouped together. So you can see in the examples here that A plus B plus C is equal to A plus B plus C, but the parentheses moved. On the left-hand side, they group the A and the B together, which means you would add those together first. And on the right-hand side, the B and the C are grouped together, so we would add the B and the C together first. It's very similar to the commutative property, but things are not moving around. We're just changing how they're grouped. And then likewise, we can do the same with multiplication. We can group the A and the B together first, or we can group the B and the C together first, and that's not going to change the product. And then again, I've got examples here where you group them differently, you're still going to get the same sum. Or if you group these differently, you're still going to get the same product. So let's take a look at the associative property here. And what I want to do is I just kind of want to insert parentheses around the numbers. I'm not going to rearrange the numbers. I'm just going to insert parentheses around what I would like to add or multiply first to make the evaluation a little bit easier. So in this first one, 2 plus 8 plus 14, I'm actually going to group the 2 and the 8 together because that's an easier sum to do. 2 plus 8 is 10, and 10 plus 14 is 24. So I can use the associative property to add those together first. That didn't really change how we did it because we would have done it from left to right anyway, but still the associative property applies. Here, 8 times 3 times 5. I actually think 3 times 5 is a little easier product to do, so I'm going to do that first. Notice nothing moved, so this is the associative property and not the commutative property. So I have 8 times 15, which is 120. This one, 13 plus 8 plus 12 plus 7. These middle numbers here go together nicely, so I'm going to group those together, and I'm going to get 13 plus 20 plus 7, and then this gives me 13 plus 20 is 33, and 33 plus 7 is 40. And then lastly, 6 times 5 times 4 times 5. I'm actually going to put 2 groups of parentheses in here. I'm going to group these guys together and multiply these together first and then these together. And that gives me 30. That gives me 20. And then 30 times 20 is 600. So that is an example of using the associative property to help us evaluate expressions. So those are the properties that we're going to be using quite a bit in this course. So familiarize yourself with all of those properties, like the additive identity property, multiplicative identity property, multiplicative property of 0, the additive inverse property, and our commutative and associative properties, and also the order of operations when we're evaluating expressions.